Heisenberg wasn't a big hit with the ladies. When he had the position, he never had the momentum, and when he had the energy, he never had the time. That joke may or may not be funny in 5 minutes. We won't know until we check and see. So I discuss science and philosophy a lot because I think that they're really interesting, but sometimes in those conversations, someone will mention this movie, and I will have to hit them. What the Bleep Do We Know has done a lot to get people interested in things like quantum physics, and I do appreciate that. But it's actually a movie about New Age spirituality, and it makes misleading references to science to try and sound credible instead of absurd. I'm not going to discuss the selective editing of interviews with real scientists to make it sound like they weren't staunchly opposed to the central message of the movie. I'm not even going to talk about how the whole water cares about words experiment was totally faked and has been thoroughly debunked. I'm going to talk about what's probably the most important experiment in quantum physics, and how a little bit of confusion about it has led a lot of people to mistakenly believe that electrons have feelings. So you've probably seen Young's double-slit experiment, either in physics class or in Stephen King's Timeline or something. It's almost as old as the United States is, and it's really revolutionized our understanding of how the universe works. The setup is actually pretty easy. You put an emitter of photons or electrons or some other very small particle behind two vertical slits in an opaque material, and then put a projector screen on the opposite side. The emitter starts shooting particles every which way, and then the fun begins. Now, if you think of electrons like tiny billiard balls, what you'd expect is that some would make it through one slit and end up here, and some would make it through the other slit and end up here. So you'd get two vertical lines. However, if you thought about electrons more like waves in a pond, you'd expect the waves from one slit to interfere with the waves from the other slit, to add to them or cancel them out in places, and so you'd get this cool sort of banding pattern on the projector screen. And that's exactly what happens. What's really weird is that even if you shoot off only one electron every few seconds so that it doesn't have any other electrons to interfere with to do the wave thing, you still get this banding pattern. But if you get curious and try to observe which slit the electron is going through, they don't make that banding pattern anymore. Instead, they make two vertical lines, just like they were billiard balls. Now this is where a lot of people, including the What the Bleep Do We Know people, start flipping out and saying, "Holy crap! Electrons care if I'm looking at them! The universe is subject to my whims and observations! I am a god unto myself!" No. The confusion arises around the word observe. When we think of observation, it's usually a passive thing, like, oh look, there's a chair over there. That's a pretty simple situation because chairs are big and weigh a lot, at least compared to electrons. So when we observe them, when light bounces off of them and into our eyes, the chair just sort of sits there. But when you're talking about something that's super tiny, like an electron, observation becomes a lot more difficult. Like, let's say that you wanted to observe an electron. Just like the chair, you want to bounce light off of it so you can see it. Unlike the chair, it's almost the same size as light, so hitting it with light is going to bump it. You might try using low energy, low frequency light like infrared, which has a wavelength of about 1 millimeter. That won't bump the electron very hard, but you won't know its position very accurately. You'll only know its position to within about 1 millimeter, the wavelength of the light that you're using to look at it, which is actually a huge distance when you're talking about electrons. Like if an electron was the size of a baseball, you'd know its position to within about 100 times the distance between the Earth and the Moon. That's pretty crappy, so you get frustrated and say, I'm tired of this ridiculously low resolution image, I'm going to use something more like an X-ray. That's a good idea. X-rays have a wavelength of only about 1 nanometer, which is much better for trying to figure out where the electron actually is. Or actually, where it was, because you just punched it like a naughty piñata with your observation. By using higher energy, higher frequency light to look at it, you just sent it sailing off. And that's why you get this different pattern when you try to observe which slit the electrons go through. It's not like they know that you're looking at them and get self-conscious. It's just in order to see them at all, you have to hit them with something. And shockingly, that changes their behavior. This is actually the foundation for the Heisenberg uncertainty principle, a really important discovery in quantum physics that allows things like electron microscopes to work, which states that you can know a particle's position or you can know its momentum, but you can't know both at the same time. And it can be derived from Young's double-slit experiment. Richard Feynman actually said that you could derive all of the principles of quantum physics just by thinking really hard about the double slit and its implications. If you want to learn more about quantum physics, or really any physics, I strongly recommend that you watch Richard Feynman's lectures, which I've linked below. I'd say that they're 1,000 times better than What the Bleep Do We Know, but 1,000 times 0 is still 0. Thank you very much for watching. If you want to bounce light off of and observe a free THUNK sticker, send your mailing address to thunkshow@gmail.com, and I'll see you next week.